fast forward a little bit of time. So on the eMachine eOne power supply, we did a repair. I put the correct capacitor in there. I actually bought a name brand one and put it in there. Shipped it back. He received it. The power supply now works, but the machine itself still doesn't work, and it makes a funny noise, and there's no picture on the output. So we still have a problem in the circuit. So this time I said, just go ahead and box up all of the boards and ship them all to me so I can go through them one by one. So this is the analog board, which is what I really wanted to look at. Because if we remember, that diode was feeding the circuit that goes to this analog board. So this analog board was pulling a ton of power through that diode for some reason. Now, I told him, just send them all to me. I'll just go ahead and plug this into one of my CRTs, which unfortunately is going to be easier said than done, because that is an unusual socket for a color CRT. Normally I see more pins here, so I don't think I'm going to have a CRT to plug this into. So what I'm probably going to have to do is just get a yoke, substitute the yoke, and then just put a high voltage probe in here as a dummy load and just leave it so I can do some testing. But anyways, so I wanted to take a look at the board to make sure we didn't have a shorted horizontal output transistor. The one thing I've noticed right away is the solder joints on this thing are just atrocious. That's broke, so that's not going to work. We got some broken ground connections going around here. We have some other questionable solder joints in the vicinity of this flyback. It's not good. So that's problem number one. But that's not our only problem. So what I've done is I've checked the horizontal output transistor here, which isn't shorted. Well, it reads shorted, but remember, you're reading through a drive transformer. But between the base and collector, we have 0.2 voltage drop across it. Now, if I go all the way back to the flyback and I measure from flyback to ground, we got that same reading. So if I do an ohms check, we're going to get somewhere around 260 ohms. Okay, that's an issue. If we look at the B plus input, which is 55 volts, if we do 55 volts into 260 ohms, we get about 12 watts of power dissipation in that resistive load. I don't see any resistor in here capable of handling 12 watts. So we're going to have to take a closer look at that circuit. Now, what I've noticed also is that 55 volts comes through this inductor, this transistor, and this diode. This is acting as a converter, and this converter is driven off of this line here of the TDA 9111, which is a multi-sync monitor processor. What that does is this is acting as a converter which adjusts the B plus level to the flyback based on the given input frequency so we can maintain a stable high voltage output. The problem is, if we have a maximum theoretical of 55 volts, which we may not, but saying if we did, we've got 12 watts of dissipation somewhere in this circuit. So I'm going to need to take a closer look of the horizontal output stage here and check to figure out where that's going, because something's up here. I don't think that's right. It might be normal. It might be. I've not worked on one of these before, but I'm just, for my own sanity, I want to go through here and start checking, because we might have a shorted diode or something, or a shorted capacitor in here that's dragging our B plus supply down, which makes sense, which is why that circuit was cooked on the power supply. Something's up here. Alright, step one is to pull the horizontal output transistor, because that's typically your go-to, because I don't want to strip everything off the board and try to, chase a red herring without at least pulling the horizontal output transistor. Now, normally when these things short, they short 0.000, pretty close to it, all the way around, right? At least that's been my experience. Now, everybody's experience is different, but that's been mine. So this is a Toshiba 2SC 5386, I think that is. I have to clean it up. Anyway, so let's test this transistor real quick. So we're going to go base to emitter. Trying to go base to emitter. It's shorted. If I go base to collector, there's my 260 ohms. How about that? That's the first time I've seen an output transistor that isn't 100% shorted. It's like partially shorted between base to collector, but fully shorted between base to emitter. That's a new one for me. So before I go any further, it could very well be possible that that bad solder joint is why the transistor failed. It's hard to say. But usually transistors just don't fail like that. So what I've done is I've removed the flyback transformer. I'm going to do a ring check on that transformer and see if anything comes back, because if I don't get a very good ring check, then we're going to have to try to source a transformer. That is likely what happened to it. But if everything comes back good, then I'm just going to chalk it up to bad solder joints, because that can certainly do it too. And, well, your ring check's fine. Doesn't mean it's not shorted under load, like if there's a bad body diode or something in there. But as far as the windings themselves, they're intact. So we might be okay there. We're not out of the woods yet, but we might be alright. So I pulled the rear shield off, which is over there. And it's much of the same thing that's going on with the main board. There's some cracked solder joints in here, especially on the CRT socket and a couple on the pins. The grounds are broken from the heatsink over here, so it's much of the same story. I've got to go through and resolder all of this, just like I did with this power or analog board here. I still got to get a transistor for it, but much of the same stuff. Alright, so here's what we got going on over here. So, I decided to order a new horizontal output transistor, and the only way I could know if it was genuine is I actually found an RCA part on eBay, and it looks like it's been through heck and back, but you know what, it's at least I know it's genuine. But before I decide to throw that transistor in and roach it on the first try, I decided to just run this without the transistor, and I noticed that this boost converter circuit here, which you can see I pulled the transistor out, was getting roasting hot within like fractions of a second. Not even 2 seconds in, you couldn't touch this thing anymore. So I was like, yikes. Okay, I don't know what's going on with that, but I figured, okay, so I decided to pull that out, and I wanted to check the drive signal going into that transistor before before I burn everything up. So I decided to pull that transistor, so now I can turn the machine on. And you'll see here on the scope what that drive signal looks like. You can see it adjust a little bit, but notice our duty cycle is 97.9%, which is not good. So that tells me that that transistor is turned fully on, which makes sense because that's going to take the 55 volt supply straight to ground, 97% of it. So yeah, that transistor's going to get roasting hot. So I decided to take a look at the data sheet, and luckily you can get the data sheet to this chip, which gives you all the details, all of the formulas and how the chip works and all that stuff. So I was looking at this DC-DC converter situation here, and we have a step-up converter, and what I've done is remove that transistor. And the way this works is there's a feedback signal that comes off the flyback transformer, and because the horizontal output transistor has been removed, there's no feedback, so it's seeing 0 volts here. So it's trying to turn this thing all the way on to get the voltage up, which is never gonna work anyways. But so that's why that makes sense why that's happening now. So I could just go ahead and whack the transistor in and find a dummy load, a yoke to put on here as a dummy load and see what happens, but I don't know if that's such a good idea. I'm wondering if I leave that out, yeah, I won't get the varying B plus voltage anymore to keep the high voltage in the horizontal stage stable across frequencies. I won't get that anymore, but at least I'll only get 55 volts here, so the transistor has a chance of surviving. Because here's the other thing too, is I keep forgetting to take age in account, because when I used to work on this stuff years ago, it wasn't that old yet. It was only a few years old. So when a transistor failed like that, there was always a reason why. Like there's a bad flyback, or there's something that causes it to fail. But nowadays, it just simply failed with age. But remember earlier, I had to replace this diode, and I replaced the capacitor next to it on this power supply because that diode failed, right? Well, that diode supplies the voltage that runs this circuit. So that makes me wonder if this failed first and then the diode failed, because I did notice that the power supply, even if it's in standby, it still produces voltage here, like 30 volts or some odd voltage. So it's going to run that thing hot. It's going to run that thing hot because the transistor has shorted and it burnt the diode up. Now, I guess the next question is, how did this transistor short? Did it short while it was in standby, because there's voltage applied here all the time? Or did it short while it was on and they turned it off and left it plugged in? I don't know. There's too many unknowns. But that's what we got going on here. So now I got to think about the next approach of how I'm going to test things. I don't quite know that yet. I had to put this fan here because this thing was getting really hot really quickly, because there's no CPU fan. So I had to put one there. Baked, 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 baked. So in order to properly test that board, I need to borrow a yoke and a picture tube. Well, what better way to borrow a picture tube than from a Power Macintosh 5200 series with crumbly bits. Alright, so the next obstacle is basically this. I got the transistor installed, and I did not put the boost converter transistor in here because I want to run this at a lower voltage, just to try to help mitigate the loss of the transistor in case there's something wrong. But the next obstacle, like I said, is this picture tube. So I need to use this picture tube as a load for this board. So the yoke, this is a multi-sync tube which came from a Power Macintosh 5200 series. The yoke is a multi-sync yoke, and that's the same plug that goes here. So that, in theory, should work. But we have another problem, and that is this CRT base. So I need to make that fit onto that, which easier said than done because they are completely different. Now, fortunately, the pinout for this one is known, which is right here. So we got a green cathode, we got the screen, red cathode, the grid, ground heater, and the blue cathode. So that's pretty straightforward. Now, this one not as easily identifiable because the Power Macintosh 5200 does not have the pinout here labeled. So I had to find a service manual. I had to look this tube up to find a service manual for the monitor that this tube was used in elsewhere. And LG made their own monitors with this tube. And I found the service manual, which allowed me to basically create this pinout here. So now I have the proper pinout. So all I need to do now is grab a socket and some wires, and then I can take this and mount it here for a proper load. But I think before I do that, for now, I'm probably just going to connect the flyback in, and then connect the ground, and then connect the yoke, just to see if everything works properly before I start fooling with this. Because if I lose the transistor, then, well, doesn't matter, does it? I'm not gonna lie, I'm actually scared right here because this has got to be the dumbest idea I think I've ever had. So I can't really work with this right now, and it doesn't make sense to just hook all this up just to nuke another transistor. So I've decided to add a dummy load to the flyback because this short lead is causing me problems. So I've got a dummy load to ground. I got this switch bypassed because I got tired of it. Did that a long time ago. So this is connected to ground. Because I'd have to ground the DAG and all of that stuff. So anyway, so that's connected to ground. The yoke is connected in here. So we're gonna do this on screen. I want to be quick. Yeah, we have high voltage. About 11, 12 kilovolts. So we have high voltage. The set is working. It's working. It's actually working. Holy crap. Alright, well, I got everything all wired up. I've got the DAG grounded up underneath and soldered to there. All of my wires are soldered in. I tried to do by color code. I took the focus lead out and just kind of, yeah, don't try this at home, folks. I have no idea what's going to happen with this, but here we go. Now, the boost converter is still disabled, so I kind of expect this thing not to work at all, but I really don't know. Let's see. Well, whoa, wow, wow, it works. Oh my god. Oh my god, it works. Wow. Alright, well, that was scary. But we're still not out of the woods yet. So, we need to restore the boost converter and put it back in here in order to know if this thing's going to fully work properly. Because right now we're only running at about 12 kilovolts, which is half of where it needs to be. So that's when the potential for anything can fail. If the flyback's drawing too much current, or if there was a yoke problem on the original tube, which we don't know, could cause this transistor to fail again. We don't know why the transistor failed originally, basically. So it's hold on to your butts time. We install the regulator, well, the switching transistor back in, which will re-enable the boost converter, because as I explained before, that boost converter will vary the voltage going to the horizontal output stage, high voltage stage, based on the given frequency. So, yeah, here we go. Okay, so the regulator has been reinstalled. Well, it's now or never. So if I'm going to lose the horizontal output transistor, it's going to be right now. So here we go. Pull it just in case. Oh, nope, we got full voltage. Oh yeah, there we go. It's working and we got color. Yes, yes, yes. It's working. Nice. Okay, now I can shut it down. I don't want to leave it on for long like this. So there you have it. Test passed successfully. So we've actually learned two things here. One, that the CRT from a Power Macintosh 5200 series, which is what that picture tube is from, which is that part number there, will actually work electrically with this particular setup, which was made by KDS. Everything on here is KDS. I even did some research on the flyback, including that brand name, and it goes back to KDS. So KDS did indeed make the eMachines eOne analog circuitry and power supply, which was, I think, just a rebadged Sotec anyways. But the monitor was made by KDS, and so is the power supply. Anyways, so we have learned that you can kind of use a CRT as a test jig, which is not a new concept, because back in the 50s, 60s, 70s, there were CRT boxes that had a big cable harness coming off of it, so you could actually test your chassis on the bench with a separate CRT. And that's essentially what I have done here. So it does work. Now, I don't recommend you do this unless you really know what you're doing. Just, that's the footnote, and that's the disclaimer I'm going to insert into this video, but it can be done. And the second thing we learned was the horizontal output transistor was indeed bad, and that's all it was. So the horizontal output transistor went bad, and that diode in the power supply went bad, which we had replaced earlier on, but who knows in tandem what happened, if that went bad because of that, or if that went bad and it caused this to go bad. It's really hard to say what happened. But changing those two parts, changing that capacitor, it seems to be working perfectly fine now. I'm not having any problems. with the CRT and all of that stuff. So I can safely go ahead and pack this guy back up and send it back off to its original owner. So anyways, if you learned something and if you enjoyed this video, don't forget to hit the like and subscribe and all of that fun stuff. Please feel free to leave a comment if you have one. Until next time, guys, thank you for watching.